Welcome to part one of lesson 1-3, which in this lesson overall, we're going to talk about absolute value equations and inequalities. In this video, we're going to focus just on the absolute value equations. Now, before we do that, I want to look here in your book at something that they have that is really important. And that is a reminder of what absolute value means as of its definition. You all are used to seeing absolute value bars. I'm sure if I gave you lots of problems where you had to take the absolute value of numbers, that you would be really great at it. But a lot of people forget this right here. And this becomes important when we start dealing with absolute value of variables, because we have to remember that the absolute value, by definition, means the distance from whatever that number is that the variable is standing for. It's the distance from that number to zero. So that's why it really irritates me when some teachers say that absolute value is always positive, because that's not actually true, because an absolute value can be zero and zero is not positive. It is more accurate to say that absolute value should never be negative, because distance can't be negative. So just a really important reminder as to what it is we're actually talking about. And the reason why this reminder is so important is because when we unpack the embedded assessment, one of the things that I mentioned is that the only skill that's new in these first few lessons that wasn't a review of Algebra 1 is being able to deal with and write absolute value equations for a real life situation. And so again, keeping in mind that it represents a distance is going to be important for that. So that's our reminder. And what we're going to look at here first is just the traditional algebra itself. So we're not starting with the real world problems. We're just starting with an absolute value. So what I want you to do in the margin over here is to write out some steps. And the book has some steps for this particular example. The problem sometimes with the steps that the book writes out is that they are specific to that problem. So, it says add 5, divide by 2. Well, of course, we're not going to be doing that in every single problem. But the gist of what they have is correct. And number one, for some reason, every single year, people always try to skip this one. And it's the most important. Step one, which has to be done first, is to isolate the absolute value expression, or the absolute value term. So get it alone, get it by itself. That's number one. You have to do that first. Can't do number two until number one is done. Number two, we are going to write two equations. One where we have, so I'll make this A. The first equation is where we have the absolute value term equal to the other side, but we take away the bars. So essentially, it's the same thing that we end up with at the end of step one, but no bars. Because in step two, we should have no bars anywhere. The second equation is expression that was in the bars Again, it's not going to be any more. Equal to the opposite of what we had in step A. Once we've written the two equations, as you might guess, we write them, we solve them next. So solve both equations. We should end up getting two answers. All right, so we're going to do just a quick example of these. So if we look at part B here, absolute value of x minus 4 equals -2. So there's not a ton of room with B, but I'm going to try to kind of squeeze it in down here. I write kind of big when I'm doing these videos because it's hard to use my little pen and make it small. But I'll try my best to squeeze it into this area so you can see it. So this is part B. And again, we're starting with absolute value of x plus 1 minus 4 is equal to -2. So step 1 is to isolate the absolute value term. So when I say isolate the absolute value term, in this case, that means this. This is what I'm trying to get alone. So if I'm trying to get that alone, that means my first step, my step 1 is to add 4, because that's going to get that absolute value term by itself. So I've got absolute value of x plus 1 equals now +2. -2 plus 4. Okay, done with step 1. Easy. Step 2, write two equations. Now here's what I mean, and here's where sometimes the steps don't make sense till we actually see an example. The first one, we take the absolute value term equal to the other side, but we take away the bars. So the first equation I'm going to solve is exactly like this, but no bars. So x plus 1 equals 2. The other equation I'm going to write, part B, expression that was in the bars, which is x plus 1, equal to the opposite of what it was in step A. So instead of +2, we make it -2. And then we're just going to solve. So subtract 1, that gives me x equals 1. Sorry about the sideways looking equal sign there. Fix that a little bit. So x equals 1. Then we also have our second solution. When I subtract 1 here, we get x equals -3. Now, we have solved it. I'm just going to write my solution up here, x equals 1 and x equals -3. It does say to graph the solutions on the number line. When you're drawing the number line yourself, you need to include all the solution values. So obviously -3 and 1 need to be on there. And then you just need to include 0 somewhere. So let's say this is -3. So then -2, -1, 0, 1. And so here we would just put our dots on our two solutions, and then we're finished. All right, one more quick one for just the algebra, and then we're going to look at the real life situation. Part D, and I've got plenty of space under here, so that's nice. First job is to isolate. So in this case, subtract 3. So I get absolute value of x plus 2 equals -2. Now, one thing you should know about all equations is if you plug back in your answer, it should give you a true statement, right? If I do that here, 1 plus 1 is 2, absolute value of 2 is 2, 2 minus 4 is -2, it works. If you check -3, -3 plus 1 is -2, the absolute value of that is 2, 2 minus 4 also -2. I can check them super quick, they both work. This one If you do all the steps, you will get answers. But if you check them, you will see that they do not work. And here is the reason. Back up to what I put stars on. Absolute values can never be negative. I have the absolute value of something, which is going to be a number because X stands for a number. The absolute value of a number equaling to a negative. This is impossible. There can't be a solution because distance cannot be negative. So I'm going to tell you that if you get the absolute value isolated and it's equal to a negative, it's always no solution. If you don't remember that, that's okay. You can solve it, you'll get answers, but when you plug them back in, they won't work. So you need to remember one of two things. You either need to remember to check all your solutions, or you need to remember to check to make sure the absolute value isn't equal to a negative. So that's your choice. All right. Last one we're going to do in this part of the lesson, in this station, is the real life situation. And they have an example here, which is great. And you should read through it kind of as an extra example. What I'm going to tell you is kind of a format for setting these up that is always going to work. And this is important. Remember that when we unpacked the embedded assessment, there is a question on the embedded where you have to do this. So the way that they have set this up is that when they wrote their equation, they have this format. So when we're writing an equation, an absolute value equation specifically, the format it's going to take is the absolute value of whatever your variable is in the situation. So in example B, it was t. We're going to subtract whatever they tell you the target value is. Close the absolute value. And we're going to set that equal to the variation amount. So when I look at this situation here and try these B, it says the pH of water is the measure of its acidity. pH of the water on the seal slide can vary up to 0.3 from the target pH of 7.5. Use this information for parts A through C. We're going to write an absolute value. So this has told us these two things. It gave us a target value here. Here I see target pH. It also told us the amount it can vary. Variation amount can vary up to 0.3. So this is just handing this to us. We're going to write an absolute value equation. It does not tell us what variables to use. Since we're describing pH, I would probably use P, but you can use whatever you want. So here, when I go to write it, absolute value of my variable, which I'm choosing P, minus the target value, which we said in here is 7.5. Set that equal to the amount of variation, which is 0.3. Solving the equation is just like we did on the previous page. One of them I set up just like the step before, except no bars. So add the 7.5. And I end up with P equal to 7.8. The other equation, I keep what was in the bars the same, except without the actual bars themselves. And I set it equal to the opposite of what I did in the first one. So negative 0.3. Still going to add the 7.5 to both sides, but here, since the 0.3 is negative, I get P equals 7.2. Now, those are the solutions. We need to interpret them, interpret the solutions. So what that means is the pH is between 7.2 and 7.8, or you could say the lowest possible pH or the lowest acceptable pH is 7.2, the highest possible pH is 7.8. How can you justify the reasonableness of your answer? These ones are almost common sense when you look at the problem. It says it can vary 0.3 from this target. So that means 0.3 up and 0.3 down. So this is really easy to check. So add and subtract 0.3 from the 7.5. That matches, and we know that it's right. All right, that's it for the first half of this lesson. You should be able to do part of the assigned homework for this now.